Alright, this is section 7.5. It's all about vectors, and we've actually dealt with vectors before. We just haven't necessarily said that they were vectors, but this is back in section 2.5, chapter 2. We talked about putting a vector on like a horizontal. This is like your horizontal, and then the J vector is like your vertical vector, and then we ended up making like a triangle like this, and it was a right triangle, and we solved right triangles from it. So basically the unit vectors is your horizontal and vertical vectors. That's nothing really new that we have talked about before. And I'm just going to go through a variety of different things that they ask you to do in this section. The first one would be draw a vector that goes from the origin, alright, to the point 3, 4, and then express it in terms of unit vectors. Okay, so if I do that, here's like a coordinate axis. Where's the point 3, 4? 1, 2, 3, 2, 3, 4. So the point would be there and up. Alright, this is your vector that they talked about. Alright, but they want you to express it in terms of your unit vectors. Well, what are the unit vectors? What's your x and y vector, or your, we call it I vector and j vector, whatever you necessarily want, but your horizontal vector is 3. The vertical vector is 4. Okay, that means your distance, if I actually wanted to find the distance of this guy, would be 5, because we know it's a 3, 4, 5 triangle. Alright, or you could use Pythagorean theorem or whatever you necessarily want to use to find the distance of a vector. Okay, or the distance formula is kind of the idea involved with it. And then your way to express it in terms of unit vectors. There's two ways to do this, okay? We call it standard form, which you say that 3 on the horizontal vector, which we call the I vector, okay? So we can go 3 I vector, that's kind of how you say it, or the notation for it, and then 4 in the j vector direction. Okay, this is what we call standard form. The easier way is to just do it in component form, which that's how it looks in component form. Instead of necessarily making a coordinate point, we got to show this as a vector. That means they actually want the entire distance from the origin to that point. Okay, and this would be what we call component form, and the one that's easiest and used most often. Okay, so once again, both forms show up in this. So this is your standard form, like I talked about before. Here's your component form. They mean the same thing. It's just saying that it is a vector. All right, and they want to find magnitude. Magnitude is just a fancy word for distance. Okay, and this is somewhat looking like the distance formula. Way back in the day, you knew the distance formula is x minus x1 squared plus the y values, or y1 minus y2, however you want to think about it. But a vector, if it is shown this way, is going from the origin to that point. So if I draw this out, I'm only going to draw this one. If I go 6 and then 8, so there's your dot, and there's your vector, okay? You now have this as 6, this is 8. They want to find the distance. Well, technically, you would go 6 minus 0, which is still 6. 8 minus 0, which is still just 8. So this is the formula you use. It's literally the distance formula. So the magnitude, which we show by like absolute value bar, that's the idea of magnitude. Okay, that's equal to the square root of 6 squared, because that's how far I'm going on the x, plus 8 squared. That's how far I'm going up on the y. So then you take the square root of 100, so it's just 10. So the magnitude of this vector is literally just 10. And what does that refer to? It is the distance of that side. Okay? Likewise on this one, a lot of you might be able to look at that and know, hey, 512, that has to share 13, or you just dump it in your formula. So magnitude would equal the square root of your distance on the x is 5 squared plus negative 12 squared. 25 plus 144 is the square root of 169, which does equal 13. So that would be the distance of that vector as well. So that is how you find magnitude. Not too difficult, because it's just referring to the distance, and we all have dealt with the distance formula before. This is a problem that's very similar to what we did in chapter 2, actually. So a vector v has a tail at the origin, so it's starting at the origin, makes a 35-degree angle with the positive x-axis. Its magnitude is 12. Alright, so they're saying makes a 35-degree angle with the x-axis. The magnitude, so that's beginning to end, that distance, is 12. Write v in terms of unit vectors I and j. So what you need to do is find your unit vector I, which is your x, essentially your x-axis distance, and unit vector j is essentially your y-axis, or the y-value distance, and you need to find that. So how would I go about doing that? And we can go back to right triangle trig if you guys wanted. So we have what? If I want to find I first, cosine adjacent over hypotenuse, I would simply just go cosine 35 degrees equals I over 12. And to solve for I, you just simply multiply cosine 35 times 12, and your I vector will end up being approximately 9.8. And then I would do the exact same thing for j, except this time it's the opposite over hypotenuse, so it's sine 35 equals j over 12. And then multiply sine 35 times 12, and j ends up equaling 6.9. Alright, now what does the question ask? Now we have solved for both of them. I know that this is the 9.8 and I know this is 6.9, but I need to write v in terms of unit vectors. So once again, you have two options. You do not need to do both of these, you just need to do one of them. Standard form says the 9.8 I vector, so that's saying the I is 9.8 units, and then plus 6.9 j vector. That's your standard form. Or you can just write it, and this is the one I prefer because it's a little bit easier, just the numbers written like that. And this is representing a vector. Okay? So either of those would be your acceptable answers to that problem. Alright? Then we have three just very simplistic things. If you want to add, subtract, and or, we'll get to the next slide, multiply, it's as straightforward as you would think. Add together the common vectors. So the I vectors can be added together. 6 plus a negative 3, because we're adding them. Okay, 6 plus negative 3 is just 3i. 2j plus 5j, 7j. That's simple. Okay? Subtracting, remember, order matters, so sometimes it might be helpful to actually write it out like this. So you minus 3i minus 5j. You must distribute the negative, or just think about it as 6i minus 3i gets me 3i. And then 2j minus a minus 5, that has to be added together. So it ends up being plus 7. Oh, nice 7. Plus 7j. Alright, so that's as simple as it is for adding and subtracting. So make sure you do those in the correct order, and you won't have a problem. Scalar multiplication is as simple as it sounds. You multiply 4 to your v vector. So it's just 4 times, what is my v vector? 2i plus 3j. So if you multiply the 4 through, you would end up getting 8i plus 12j. Alright, so any scalar multiplication, that's as simple as it has to be as well. Alright, the last thing, which may be new for some of you, is we're going to be talking about the dot product. Okay, dot product or scalar product is literally not necessarily like multiplying the scalar multiplication like we did back here. This is different. Okay, what we're going to do is on your salmon sheet, we're going to end up using this formula right here. So I'm going to want you to find that. It's finding an angle between two vectors. And this dot product is used on the top part of that formula. Now I'm going to show you how this dot product works as a separate problem. The dot product is literally just taking your x component, or your I vectors, multiplying them together. That's the a times the c that you see right here. And then you're going to add that to the y vectors, or your j vectors, multiplied together, and that's the b times the d. And then you're going to end up getting a physical number here. It's not going to be a vector, it's going to be literally a number. So in this particular problem, dot product of uv would be 3 times 2 plus the y vectors multiplied together, y components, I guess I should be more specific, and you end up getting what, 6 plus 20, and that equals 26. And what you would end up doing then is using that 26 in the formula that you see on the next page. So if I just ask you for the dot product, this is all you do. Normally I won't necessarily just ask for the dot product. I'm going to have you use the dot product so we can find an angle between two vectors. Okay? So here it says find an angle between these two vectors. So if I draw these out, I'm just going to try to give you a visual of what we're actually asking for. We have what? 6, -1. So there's my dot. This is vector. It's vector u. And then -1 up 4 is there. So this is vector v. And I need to find the angle, or want to find the angle between these two. And that's the idea that we're looking for on this particular problem. So to do this, you do this calculation. So cosine theta equals, let's find the dot product and then each magnitude separately. Okay? So dot product, u dot product v, would literally mean what? 6 times -1 plus -1 times 4. So -6 plus a -4 gives me -10. So that is going to be the number that goes on the top part of the fraction. Okay? The bottom part has two magnitudes. Now we've dealt with magnitude at the very beginning of this lesson. So the magnitude of u would be the square root of what? 6 squared plus -1 squared. So it's the square root of 36 plus 1 is 37. And then the magnitude of v, square root of -1 squared plus 4 squared. So that'd be the square root of 17. Alright, now let's dump it into your formula. Now once again, try find this on your salmon sheet. You will not have to remember this formula. It will be there for you. And all it is cosine theta equals the dot product, we already calculated as -10, over the bottom, which is the square root of 37 times the square root of 17. Now you may want to combine these into one big radical, or make sure your parentheses are done correctly. So now you have to take the cosine inverse of that fraction. Okay, like I said, as long as your parentheses are set up correctly, your theta, the angle you get, should be 113.5 degrees. So you guys should practice that at least once to make sure you know how to calculate that. And if you can get that, life should be good. Alright, so that is how you use that formula, how to find an angle between two vectors. Just to note that if two vectors are perpendicular, their dot product is going to be 0. Okay, perpendicular, 90 degrees. Okay, dot product is 0. That's the top of your fraction. What's the cosine inverse of 0 over any number that you want down here? Whereas x0 is 90 degrees. So that's why that's true. Just going to kind of make that point. We're going to be looking at problems 1 through 35 on that section for tomorrow, and then application problems. So we're going to go into talking about word problems and dealing with all of that, and that'll be on Wednesday. And just want you to be aware. So hopefully you all have a wonderful day.